exactly 7 days ago, we talked about this part. I will do a little bit of revision, a short revision to go through what is the important things for that exercise. This is very important for like talk about transformations. I haven't finished the last bit. I will go through that later. So we talk about like instead of giving the words, we give a matrices to talk about what's the transformation. So can present dilation and reflection by like a 2 times 2 matrices, and we have like particular ways to write it. For example, if I give you this one 1 0 0 2, you know now that should be a dilation by a factor of 2 from the x-axis, and if 2 is instead of y, like we swap the y and 2, that will be dilation by a factor of 2 from the y x-axis. And same we can do, also we can do like a dilation, 2 dilations in the same box. So that the dilation by factor of 3 from the y and the factor of a half by the x. Then we can also do reflection by the similar way. So we can do negative the first one is a reflection in the y-axis, the second is reflection in the x-axis, and the third one is reflection in both axes. And there's a special one when we not really talk about that in the wording, is the reflection in the line y equals to x. And you know that's the swap for x and y values, and that's actually the inverse. So replace on the left corner to right corner diagonal, we change that to 0 0, and the other diagonal change to 1 and 1. That means a swap for the x and y values. So x dash become y and y dash becomes x. And we don't really talk about the negative reflection. So that's the matrices can represent the transformation. And also if we talk about the translation, that's a 2 times 1 matrix to talk about the horizontal movement and vertical movement. If it's moving to the left or moving down, it will be negative values. And we add that at the end. Okay, we add that in the end. Or if that happens first, we'll bracket. Oh, sorry, that's the rubber. If it happens first, we'll bracket that first. So that happens first, and then by a dilation, we will still the calculation order will be the same as the transformation order. And then we talk about how to use matrix to find the point transformation. And we haven't really finished this one. So I'm not sure if you complete this already, but that's not really something will be tested. Okay, that's not really something will be tested, but it's a good thing to understand what is a transformation. So transformation is not only those things we talk about, like always have 0 0 on the diagonal. It might have like with 4 numbers. That's why at the beginning I can't say one diagonal is 0. I will put A, B, C, D there to say I'm not sure if there's number or not. I will try. And then the t times the original. Okay, the key formula is the t times the original coordinates should give you the new coordinates. So it's t times x give you x dash. Okay, that's the formula we have. So a, b, c, d times the original coordinates give you the new coordinates, and same as the other point. Then we set up 2 equations, and because of the matrix equation, we need to have the top 2 equal and the bottom 2 equal. So we can find 2 simultaneous equations by expanding this, okay, by expanding this. So it's always set up the matrices expanded and then rearranged to the required form. Now we have solved out A, B, C, D values. I hope you have done this at home already, because last time we did it really quick. We have A, B, C, D value here. Now it asks us to find the image of -1 and 1. Okay, ask us to find the image of -1 and 1. So let's have a look. What's A, B, C, D? So A is -1/2. B is -1/2. D is 5/2, and C is -21/2. I hope I get this right. If anyone get a different answer, please let me know. I think I get this A, B, C, D value right. And I will times this by -1 and 1, because that's the original coordinates. Okay, that's the original coordinates. Okay. Something we can think smartly. because we all have denominator 2 here, and most of the ABCD got negative. So what I can do first is take a negative out, negative a half out. Then I have 1, 1, 21, and negative 5 here, which is easy for me to do the calculation. So that's just something, you know, like you can times the factor in, you can also take the factor out from the matrix. It's nothing wrong if you don't take it, it's alright. But I feel it's just easier to think about this way. Questions? Questions? Yes?
Why do you multiply ABCD by the negative 1?
Oh, okay. What's ABCD? ABCD, I'm not sure if you remember, ABCD is the transformation matrix T, right?
Okay.
And T times the original coordinates will give you image.
Yeah.
So it's asking for image. So that's why we times T and the X together. So, well, we calculate the matrix row times column. Okay, I still like this way to do it, to circle it. And don't forget you negative a half in the front. Okay, we can times 2 times 2 and 2 times 1 matrix together. So 1 times negative 1 is negative 1, 1 times 1 is 1. Plus them, you have a 0 here. Okay, and then 21 times negative 1, you have a negative 21. Negative 21. Minus 5 times 1, you have minus 5. And you add them. You have negative 26. Now you can put this into the matrix 0 and 13. So the coordinates will be 0, 13. Okay, just show you where's the matrices in the calculator. If you press the button next to 9, okay, you can see this box I highlight here is the matrices box. Well, it's easy. Well, we have 2 times 2 matrix here, but if one day you need like a 4 times 5 matrix or something like that, you want like different numbers, I don't think you will get to that case. But if you get that case, you can press this one. Can you see this one with 3 times 3? You click on that one and you can change the number of rows and columns by yourself. But if you just want I don't want this one. If you just want a 2 times 2 matrix, is just here. Okay, 2 times 2 matrix, just click on that, you have a 2 times 2 matrix. For example, I times 1, well, exactly this question here, 21 and minus 5. And I will times, okay, press the times button, times a 2 times 1 matrix, you will do for that one, okay? This template is already, wrong place. Move it out. I can't move it. That's so sad. It's alright, just do it again. 1, 1, negative 1, and not negative 1, that's 21, and negative 5 times 5, okay. Okay, that's working. Times by negative 1 and 1. Okay, it's just like number calculation. You just need to find the template and exactly enter the same thing. And we have 0, negative 26, and we can times negative half in, and you can do that by yourself. Or you can also do negative 1, 2. Well, if you really don't want to do calculations, I hope you not like that, but we can do that. Okay, we have 0 and 13. So you can do all this calculation. What you write on the paper, if you can find the template, you can enter into the calculator and then do it. Okay, so nothing difficult for the matrix. You just need to find where is it. And that's the final answer for this one. We have 0, 13. Okay, we have 0 and 13. Okay, and well, don't have much time. I just keep moving. And for the next one, we talk about a really important thing here. Anyone remember what I have talked about for this question? What I said, what is important here? Yeah? Like one word, give me one word. What is important? Order, correct. Order is important. Good. Okay, instead of explaining a lot, the order is important. The first matrix must times we get the closest to the original coordinates, and anything happen after that, we need to keep times it into the front. Okay, we keep adding things into the front. That's very important. I believe you have similar questions in the textbook as well, which order is very important. So we'll time things into the front, and then we do the normal calculations. Nothing really difficult here. For this question, I also explained whether dilation happens first or reflection happens first, it doesn't really change the final answer. So if you swap T1, T2 in this case, you won't see different answers. Okay, you may not believe me why it's important to see the order, but because when we change the order of this transformation, it's not really changing the final answer. That's why how you write the matrix is not going to change your final answer. But if something like reflect in the line y equals to x, and then dilate by a factor of 3 from, doesn't matter which axis, maybe from the y-axis, then if you write the matrix in the wrong order, you will have different answer. Okay, then you will have different answer. When you talk about reflections and then dilations or reflections combined with reflect in another line, for example, in reflecting the y-axis again. So when you combine the reflect in the line y equals to x, then the order is very, very important. You will definitely get different answers. Okay, you definitely get different answers. Okay, so that's what I talk about. So order is important. And for talk about x dash equals to t times original plus the translation matrix B here. Okay, that's the equation, and we just do all this expansion here. And as required, it asks us to find x, y in terms of x dash, y dash, and I did that. I just do all the expansion. I set up the matrix, do all this expansion, and rearrange this algebraically. Okay, that's what we learned last week. Okay, exactly 1 week ago. I hope that can give you idea on what's going on last week. And we move on to the next question, which is the last exercise we have for matrix. Well, it's a long chapter, I know, but this one is the last one. This one is equivalent to, okay, this is equivalent to give you the wording and ask you for, I will use that. I think we're familiar with that. Step number 1, step number 2, and step number 3. Well, it's asking for what is number 3 and give you this one, give you what's the original equation, x and y. But number 2, it should give it words like reflect in the x-axis, dilate by a factor of what word. Like instead of doing that, they give you the matrix. Okay, they give you the matrix. They replace the word by the matrix. But as I said before, it is all the same for what? Okay. Transformation description is the same as giving you x dash equals to sum x, y dash equals to sum y, and same as give you the matrix. So they can, 1 can become 2, 2 can become 3, 3 can go back to 2, 2 can go back to 1. So they are all the same thing here. So giving you the matrix, it will be the same as giving you the word description. So let's have a look at this question here. A transformation is defined by the matrix 1, 0, 0, 2. Okay, by looking at this matrix, can you tell me what is happening here? What transformation is happening here? Yeah, from the x-axis. Dilation by a factor of 2 from the x-axis. Then find the equation of the image of this graph. Well, we can do 2 ways. Because by just looking at this matrix, we know what's happening. It's same as giving us the words already. Dilation by factor 2 from the x-axis. So what I can write is y dash equals to 2y. That's really straightforward because this matrix represents that. Okay, that's what I can do. Or another way we can do this is t, well, I'm better say, the new points equals to t times the original points. Okay, that's another thing we can have. If you can't see, okay, if I can't see, that's all right. If I can't see what's happening here, that's all good. Like, I can just set up the matrix because x dash equals to t times x. And we can do expansion here. Well, you know when we set up the matrix, we must do expansion. So row, column is x and 2y. Well, what we have here, x dash equals to x, nothing changed for x. Y dash equals to 2y. By reading this, you will know that this is a dilation by a factor of 2 from the x-axis as well. Okay, you can use a middle step to help yourself to find what's the wording description. So that's another way we can do it. Okay, what's the next step we can do? What's the next step we should do? After we change matrix into y dash x dash, it back to the original question. So give you the original equation. So step number 1, 2, and 3. I'm looking for 3. I get my x, number 1 get y equals to x squared plus 2x plus 3. And I get number 2 is y dash equals to 2y. What I should do after that? Yeah, I heard substitute. Can I substitute now? No. Okay, what I need to do? Yeah, make x and y. X, I don't need to worry about x. Nothing changed for x, but I will make y equals to a half y dash. Because I have y, I need to replace y by a y dash. So a half y dash equals to, well, it should be x dash squared plus 2x dash. I'm too lazy to write that because there's no change for x. Then I can have y equals to 2x squared plus 4x plus 6. We can see it's nothing really different from the previous exercise. Transformation matrix is just another way to give you the wording. Okay, just another way to give you the wording. So everything is exactly the same as before. Okay, after you finish this one, can you use 6 minutes or 5 minutes now to try example 2? Okay, to try example 2. Remember the step is set up the matrices, expanding it, make either x dash equals to something or x equals to something, y equals something, y dash equals to something, and do the substitution as required, like what you need, you do the substitution. So try example 2. Set up the matrix according to what is given. Okay, you have 5 minutes to try that. Okay, let's have a look. We have some difficulties to recognize what is x dash. Just let you know again, x is the matrix xy and x dash is the new coordinates x dash y dash. When you deal with matrix, you need to have everything in matrix form, otherwise you can't really add them. So according to what they give you here, you just expand it. Okay, just expand it. So what we have here is 0, -3, 2, and 0. Can you see in this matrix T, there's, I think, at least 4 things happened? Well, I don't know what's the exact order, so it's very hard to talk about it now, like by just looking at a really complex one. But what I can see is there must be a dilation from some direction, another dilation from some direction, a negative is a reflection in some way, and also the y equals to x is get reflected in that line as well, because you don't have y and y here, you have 0 and 0 here. So at least 4 things happened by looking at this T matrix, but I don't know the order. Okay, I don't know the order. I can figure it out, but like, why not just expand it and see the equation directly? It's not really requiring us to describe it. So instead of doing this, I will just expand it. But it's good to see like what kind of transformation we have in this T. And then we have x. So it's x is xy plus b. b is 1 and 2. Okay, remember the bracket. A lot of you forget about the bracket. And that equals to x dash and y dash. So the new point equals to, can you see here, there's a translation to the right of 1 and up for 2 units first. Okay, that happened first because it get bracket. Okay, that bracket. So what we do for the calculation is 0 minus 3 to 0. Okay, times with x plus 1 and y plus 2. Okay, even though it's a little bit fat, but it's still a column 1. Okay, 1 column matrix. It's not a 2 columns matrix. So because it's a little bit like more things, but it's a number. So that's why I like to circle things. When I circle that, I know that's exactly 1 column. Okay, I know that's 1 column. And I have this row and row. Remember that still equals to x dash and y dash. And you just keep expanding things. Okay, to expand this, can you see 0 times the first got 0, negative 3 times with y plus 2 with a bracket. That's the second times second. For the next one, I have 2 times x plus 1, but 0 times that gives me 0. Well, many of you expanded, that's alright, nothing wrong. Okay, I can keep in this form or expanded form. That's all good. But what x dash equals to? X dash equals to minus 3y plus 2 and y dash equals to 2x plus 1. It's not that friendly to just keep things in the matrix. It's very long and hard to write. So I will get out from the matrix form as quick as possible. So that's what I will have. And the question back to, I have number 1. Number 1 gives me y equals to 2x plus 5. I have my number 2 here. My number 2 gives me x dash equals to minus 3y plus 2. That's the result I get from the matrix. And number 3 is the question mark, but I need x dash y dash. Okay, we know that we need x dash y dash. Okay, question go back to 2 weeks ago. Okay, how we can, by knowing number 1 and 2, we can get number 3. So we can get number 3 by substitute things to it. Okay, by substitution. Because I need to replace x by y dash and replace y by x dash. So I need to rearrange the equation to get y equals to minus a third x dash minus 2 and x equals to a half y dash minus 1. Okay, that's by rearranging the equations. By rearranging the equations. Okay, that's the question mark. I need x dash y dash. And what I want to do is substitute. Okay, y will be replaced by this. Okay, now I don't have y, I have x dash. And 2x. X is a half y dash minus 1. Okay, that's 2x plus 5. Okay, so that's y equals to 2x plus 5. Okay, minus a third. Well, I can get rid of the x dash now. Y minus 2 plus 5, that's a plus 3. Okay, and y equals to negative a third x minus 5. Okay, that's by rearranging. But do you know, like, I can rearrange things in the calculator? Well, hope everyone know that. So I can go menu 3-1. Okay, you can see that later. I'll just do the calculator bit. 1 over 3x minus 2 equals to 2 times bracket minus, do you have the minus? No, we only have a half y. 1 over 2 times y minus 1 plus 5. And because I need y to be the subject, I can go comma y to rearrange it directly. So that gives me negative a third x minus 5. You just type whatever you need to rearrange in and make the thing you want to be the subject. So y needs to be the subject, just comma y. And that gives me an expression y in terms of x.
You don't need to do any of this.
Yeah, Yeah. But only if you can use calculator in the test. Otherwise, you need to still do this by hand. Maybe it's in exam 1, who knows? But that's the skill you can use for this test. You can rearrange it by calculator. Okay, any questions? Questions? No? Okay. If you don't have questions, can you cross out this part for me? Like last page, part D. I don't need part D. Okay, because we haven't learned 7F. I can't remember which one is that, but you can cross out D. We don't need D. Okay, you just do A, B, C, and E. Okay, very important for C and E. Okay, very important for C. Okay, you will have something really similar to this in the test. So C is very important. If you don't have any questions, I want you to use the rest of time to try this one, and that's what we'll do from Thursday. Wait, today's Wednesday, right? Do you have class tomorrow? Okay, we'll finish that in Thursday, and then Friday we do revision. Yeah.
So we do A, B, C, yeah?
Yeah, if you can do A and B. Like it'll be a little bit tricky for A and B, but C definitely you can do them. Okay, so try them. A, B, C, and E, 4 questions. We'll start doing this tomorrow. If you can't finish today, do it as homework. Okay, do it as homework.